Hey, this is Jody with weldingtipsandtricks.com. This week we're fabricating a Jeep bumper, really putting together a Jeep bumper kit from swagoffroad.com. And I'm going to do like I said in one of my recent videos where I'm going to use very crude equipment. I'm going to use nothing but a AC BuzzBox Lincoln Tombstone welder. That's really all you need, something like that, to put together something like this, which is a nice heavy-duty Jeep bumper. I built one of these already several months ago, just used a MIG machine because that makes most sense, but not everybody's got a MIG machine, or not everybody's got a good MIG machine, but most everybody has access to a little AC stick welder BuzzBox. I'm going to use 7014s that I got at Tractor Supply, and I'll use 6011s to do a little tack welding with. 7014s, I showed this in the last video, will pretty much run themselves if you have the heat set right. This is just a stinger, unattended, burning the rod off pretty much by itself, and it'll run a pretty decent bead like that. And so a rod like that it's very much like a 6013 rod, just a little more strength. It runs very much alike, and I don't really care for 6013s, but a lot of people do. A lot of people use them, and they do work. Very easy to start. But you do have to set it up hot enough to get good results. So I set this, did some test runs, and 150 amps seemed hot enough to avoid those wormholes and things that are common with 6013s and 7014s. So first off, I'm going to put the little receiver hitch and get a center line, and I'm making two soapstone lines well outside the square tubing, so I can then set it down and eyeball it and get it centered up, and then I'm going to check for squareness to see where that first tack needs to go. And it needs to pull that way, so I need to put the tack on the side of the square. If I put it on the other side, I'll never get it square. So I'm going to put a tack here, and if you watch closely, you can see it draw. As soon as that tack solidifies and cools, you can watch it pull towards me. I'll show you it once again here. Watch closely. See, it pulls a good 1/8 of an inch. And it pulled just a little bit past where it needs to be, but the tack that I put on the other side now will pull it back down square, and that's kind of what you do. Unless you can clamp everything down really tight, which I rarely do, just because sometimes you just need to get a tack on it, and then you can work with it a lot better than trying to get everything perfectly square before you ever get that first tack. That works out good for me. Everybody's different. Everybody's got their own techniques and tricks and methodology and whatnot, but I'm putting my tacks on all four corners here, and I'm using a 6011 rod to tack because it starts really easily. 6011 doesn't take as much amperage, it doesn't have as heavy a flux coating, and it puts smaller tacks that are much easier to go over with a bigger stick rod. So I'm tacking with 6011, and I'm going to weld with 7014. And see, this has got a mill scale type coating on there. When you're stick welding stuff like this, that is one advantage. You pretty much don't have to prep the metal nearly like you would with other methods. The stick will burn right through any mill scale coating that's on something like this. It's a pretty light coating too. This is clean metal. So you can see how it just goes together here. It's got a little dimple die punched, kind of like a sheet metal shroud, and it holds the support tubes. It holds them right up against that receiver tube, and it's very easy to put together just with a couple of pony clamps is what I wound up doing there. And I've got it close enough right now, not perfect, but I got it close enough that I want to get tacks on the ends, and then I'll work with it a little bit and see how everything else is. But it looks like it's pretty straight. So with those tacks on there, now I'll remove the sheet metal piece, and then I'll just do some welding, get some more tacks first. Right here, again with a 6011 rod. I've got that fan on behind me, and I've got a roll-up door rolled up, so I'm using natural ventilation here. But that is a good thing about stick. You don't have to worry about the fan blowing your shielding gas away, and you put a fan on one side of you blowing the smoke away, and you breathe a lot less fumes that way. Now with a 7014, like I said, you need to have enough heat to where that arc force keeps that molten slag, molten flux pushed back and backward out of the puddle. If you run it too cold, too cold with a long arc or things like that, you can wind up with a bead on each side, and it doesn't even join in the middle, and a slag trail down the middle, which is one of the things I don't like about them. They do have a kind of a heavy slag coating, and they're not a very deep penetrating rod. But if you set it up hot enough, you can do just fine. See, even at 150 amps, it's not exactly, you know, digging like crazy, but it's laying down a nice flat bead. It's not cold at all, and I'm able to use all kinds of electrode angles, and it's pretty forgiving. I'm keeping a really tight arc. And as you saw just a minute ago with that electrode burning itself, that's pretty tight arc. It just, the flux just resting on the metal, kind of like this. Okay, well that's the four sides, and we'll wait and chip all that off later. Well, actually, there's one side left here. I'm sorry. I wanted to show this because I'm using a really extreme electrode angle, and that's why you're seeing the BBs. But it still runs good. And actually, a good angle like that can really help push that flux back to the back of the puddle and not trap slag and not make wormholes and things. Even though I've got a little spatter and little BBs here and there, they come off very easily, and it works. So the next thing I'm going to do is get some tack welds on these toe lugs, which they have a little tab on them, and the main part of the body is laser cut. So all you got to do is pop them in, tack them, and weld them. No locating or anything. It's pretty easy. Trying to have a few less tie-ins, I'm going ahead and wrapping that corner before I make the long run, and just have as few tie-ins as possible. Again, 150 amps, and this is a 1/8 or 3 millimeter 7014 rod. Now, if you have something that you don't want to reposition too much and you want to weld downhill, 7014 is not the rod to do it with. I'm using a 6011 rod here to go downhill. Or if you have a little gap that you want to weld downhill, and I've got one later in the video that I'll show you, 6011 is a really good rod. 6011 is the AC version of 6010, runs very similar, and it is works well for going downhill when you need to. So now we're welding the little angle cuts on the support tubes. Again, kind of a distinct angle at first, but I'm going to try to, you know, correct that as I go and get a better angle as I turn my wrist here and try to go completely halfway around the tube. So I only have to make one, you know, one stop and start. The tube is a little bit, you know, thinner wall thickness than the main part, it seemed like anyway, and so 150 amps was really cooking pretty good on that. All right, we're getting there. You see the gaps like this where the main part is high strength steel, and it's CNC bent on a press brake, but it does leave some gaps on the corners, but really easy to fill. I'm just going downhill here with a 6011 rod, sewing that gap up, no problem. The 7014 will fill a gap really easily, just not so well downhill. So if you want to weld the gaps like this using the 7014 rod, flipping it up, just flipping it up flat. I tried some using copper backing on the bigger, but it didn't really need any backing. I did turn it down just a little bit. I think I turned it down to about 120 for these gaps. 150 would just chew the corners right off. But with a short lead, it's only like 10 or 12 feet long. Reaching over to the dial, up and down here and there, a few amps, pretty easy. Here I am using copper backing, a little copper bar. You could also use aluminum, just in case it wants to fall through. I'm getting that weld started by jumping from corner to corner. And you can see that the rod fills that gap pretty well. Copper backing does help, though, keep things from just falling through if things get a little too molten. Now, a grinder with a wire wheel is part of the equation if you're going to fabricate using a stick welder like this. So I've got a wire wheel on there and cleaned it up. And then the last thing is to put this little rolled sheet metal piece. It's an 1/8 inch thick. And because I wanted to weld that receiver thing all the way and get all the welds all the way around on the support tubes, I decided to put this on last, and I just needed to trim a little bit. to compensate for where I welded, so that it would set down flat. And I still needed to dress the welds just a little bit to get it to sit down nice and flat with a really very few gaps here and there. So once I got that all clamped up, I get a few tack welds, and then we'll weld it up, and it's just about finished. So I'm going to weld that the where it joins the main part of the bumper there, and then weld it up where it joins the square tubing where a trailer hitch goes in, the receiver thing there. That's about a wrap. So that's just a little quick bumper kit done with nothing but an AC buzz box and a portable welding table from Strong Hand Tools and a grinder. Not much else. Now I want to take the doors off this Jeep and ride around because the weather's pretty here. So I bought these Harley mirrors, and I got to modify them. I thought I might have to. The shank isn't quite long enough to get a nut started on there, so I'm going to go ahead and cut these real quick. And I'm going to cut them on a little portaband on a portaband stand that I built some time ago. Now, Swag Off-Road sells these for Milwaukee and DeWalt, but I had a Porter cable, so I went ahead and fabricated my own. But anyway, I trimmed it off real quick, and I'm just going to weld what's left of the mirror to the head of the bolt. These are 3/8 by 2-inch stainless bolts. That's about 9.5 millimeter by 5 millimeter for the metric folks. And one of the most handy things you can have for holding stuff like this is a little machinist vise or little drill press vise. Just a cheap one for small parts. It's very handy to put stuff in to weld. And another thing that's handy, this is a very crude third hand here. I didn't make this one. I just pulled it out of a scrap bin somewhere. But a third hand is just a 3-point type thing, and I put silicon bronze on all the tips here to transfer the ground where I don't get any arcing, because sometimes I work on parts that really can't tolerate any arcing. But these are handy little dealios too. You can hold something like this while you can get a tack on it, and you can make them out of most anything. You can find stuff in the shop, some round stock and anything that's heavy, and 2 legs and 1 snout, and you got it. So I want to get a couple of tacks on this thing and then weld it out, and then we'll put it on the Jeep and see how it works. So I set it down in the drill press vise just like that, and then welded it out. Didn't even really need filler metal. And there it is on the Jeep. Works just fine. And here is the website if anybody's interested in some mirrors that will slip down into the Jeep doors like that, but they do need to be modified. And now it's time for just a quick test ride here. It is a free feeling driving down the road without the doors. Probably not as the safest thing in the world if somebody T-bones you, but hey, life is short. New t-shirt design is ready. Go check them out at weldmongerstore.com. Thanks for watching.